Okay. Section 2.4, solving for x. Okay, let's just dive right in. So it starts off where, do you remember equations like this where you're supposed to solve for x? In other words, get x by itself. And, this is presuming, in this class that you've had experience getting x by itself before in these equations. Remember, I can call these equations because there's an equal sign. So this is not just an expression, it's an all-out equation. It's got an equal sign, which breaks this up into like a left side of the equation and a right side of the equation. So equations have two sides, where it says one side equals the other side. And, that it's literally a statement saying that two quantities are equal. Number one, for example, is saying that the quantity of x plus 8 is exactly equal to 15. But anyway, let's actually get rolling here. These first four quick examples, again, we're like assuming that they are like a prerequisite, something that you already know from before, where in this one, in number one, what would you do? How would you get x by itself on the left side here? Well, you'd want to get rid of this plus 8. And how do we get rid of adding 8? Like, what's the opposite of adding 8? We subtract 8 from both sides. Because whatever you do to the left side of the equation, you also have to do to the right side of the equation in order to keep the two sides equal and balanced. So if I minus 8 from the left, I also got a minus 8 from the right. And so that will pretty much leave the left side as just an x. And on the right side, 15 minus 8 should be 7. And once we get x by itself, we're done. And we've solved for x. And it turns out that x equals 7. And just to be pretty thorough here, what this actually means, if the solution is 7, all it means is if you let x be a 7, it makes the equation a true statement. It's like, what plus 8 equals 15? Well, 7 plus 8 equals 15. So the only number that the x could be to make it true, to make this whole equation true, is 7. Anyway, let's bang the rest of these out. How would we get x by itself here? What's the opposite of subtracting 4? Adding 4 will kind of like undo that. But whatever we do to the left side, we have to do to the right side as well. And so the final solution would be 21. In number 3, what does this say? This says 5 times x. So what's the opposite of multiplying, in order to get that 5 out of there? So x is by itself. We would divide by 5. All right? It's funny, today in class we literally talked about how make extra sure that your 5s don't look like s's. Anyway, getting back on track. So if I want to get rid of this 5 as 5 times x, we divide both sides by 5. And so 35 divided by 5 should be 7. And then I guess the other possible situation, one of the other possible situations, is that if you had x divided by 4 and you wanted to undo and get rid of that 4 so that x was by itself, you think like, what's the opposite of dividing by 4? It's multiplying by 4. So that'll sort of cancel out that 4 and leave x by itself. And on the other side, 20 times 4 is 80. I don't know if you need your calculator for that. But so anyway, those 4 problems should be like, stuff that should already be pretty familiar, and it should be a pretty learned skill already before we even do this lesson, or before we even took this class. So let's get into some, I guess some more involved examples. And you know what? Maybe you already know how to do these as well from a past class. But we want to get x by itself. But like, look at the left side. It looks like we have this 2 to get rid of, where it's like 2 times x. But we also have this plus 5 to sort of deal with in order to have x be the only thing on the left side. You might remember in middle school, maybe this applies to you, drawing a line, like actually drawing a line where the equal sign is, to like really emphasize the fact that there is a left side of the equation and a right side of the equation. But anyway, so it's like we need to deal with these 2 things. Well, which one do we do first? Well, this hint in blue up here basically says we want to get rid of this plus 5 first. That is a thing that you need to understand. We're going to deal with the plus 5, then the 2, in that order. It's important. So how do we get rid of plus 5, adding 5? We subtract 5 from both sides. And so the plus 5 is gone, and the 2x remains. And the right side becomes 11 minus 5, 6. So now we're here. Okay, we're not done yet. Okay, it's more than one step. Big deal. So now what do we still have to do to get x by itself? Well, this is 2 times x. What's the opposite of multiplying by 2? Dividing by 2. And so that frees x to be all alone on the left side. 6 divided by 2. The right side has to stay balanced, becomes a 3. 6 divided by 2 is 3. Well, so that's what we're going to kind of follow those rules. So over here in number 2, we have to deal with this 5. So here's the equal sign. So on the left side, we got to get rid of this plus 5, and we got to get rid of that divided by 3. We're going to do this first. We're going to undo, the adding 5 by subtracting 5. So that would leave x divided by 3. 9 minus 5 is 4. And so now, we take care of this x divided by 3. What's the opposite of dividing by 3? Multiplying by 3. So that's going to cancel that out, and x will remain all by itself. Oh, sorry. 12. So x equals 12 is the final answer. Okay, slightly different kinds of examples, just throwing different things at you here. How would we deal with 2x minus 4x equals 12? How are we going to solve for x? In other words, get x by itself. When you see x appear twice, like here's an x, here an x. Well, basically what you want to do is you want to get the x terms together so that they combine, but they have to be on the same side. If you're going to combine like terms together, they've got to be on the same side, Like back here, you could, in a way, I'm not trying to confuse you right now, but this plus 5 and this positive 11, those were technically like terms that you want to put together, right? But the positive 5 and the 11, positive 11, they weren't on the same side. So before you could combine them together, you had to get them on the same side. But anyway, we'll kind of describe it like that a little more as we go. But in number 3, look at this, 2x and then minus 4x. Those are like terms. You can combine those together as they are like terms. And they're already on the same side. So we can just take 2x minus 4x and just do that and combine them together. So 2x minus 4x is negative 2x, which brings us to here. So what do we do with this? Well, now we can sort of really get back to getting x by itself. And the only thing to do to get x by itself is sort of get rid of that minus 2. And it's minus 2 times x. And how do we undo multiplying by negative 2? We divide by negative 2. So whatever's being multiplied to the x, we divide both sides by that. And then 12 divided by negative 2 is negative 6. And as always, once x is by itself, you're done. Number 4, are there any like terms that are already on the same side of the equal sign? And the answer is yes. Negative 2 and a positive 7, those two terms are already alike and they're already on the same side. So my first move is going to be combine them. What's negative 2 plus 7? I hope you see that it's positive 5. So that's all we're going to do in that step. And then after that, I can sort of really, turn my attention towards getting x all by itself. Well, just like before, the first thing we would do is undo the adding of 5, the plus 5. So that's going to leave 7x still over there, and then 26 minus 5, the right side becomes 21. And now I would divide both sides by 7 in order to get x all by itself. And the right side would become 21 divided by 7 is 3. And we're done. Okay, man, look at all these nice hints. When you look at number 5, as we do all these examples, the full, step-by-step plan of attack seems to be revealed, everything that there is to do possibly and what order you would do it in. So I guess with number 5 and number 6, I can kind of point out that if there's any parentheses in your equation, any bubbles, any groupings, that is probably the first thing you want to do, right? Before starting to get x by itself and combining like terms that might be already on the same side as each other, the first thing you might want to do in any equation like these is to clear the parentheses via the distributive property. So in number 5, the very first thing I'm going to do is distribute the net, because it says negative 4 times this entire bubble, right? It's negative 4 times both of these terms in the bubble. So negative 4 times 3x, that is negative 12x. And then negative 4 times minus 1 is a plus 4. So that's my first move. After that, after clearing parentheses, then I would check for are there any like terms that are already on the same side? And in this example, there is not. Negative 12x and positive 4, they're not like terms. Those would not combine. So I guess I can just start, getting the x's together on one side. That doesn't really apply here. I only see an x one time. It's not like here's a little foreshadowing here. Foreshadowing. Eventually, we're going to be in a situation where there's an x term on both sides. There's like an x over on this side, and maybe there'd be an x over on this side, and we would need to get the x terms together on one side so they combine. That's foreshadowing, though. That doesn't apply in number 5. There's only an x here, so we can just start getting it all by itself. And when you look at, do I get rid of this minus 12 first, or do I take some action to get rid of that plus 4 first? Which one do I take care of first? It's got to be the plus 4. You take action to get rid of this first. What's going to make plus 4 go away? By subtracting 4 to both sides. So we still have a negative 12x over here because that's gone. 16 minus 4 is 12. Now I can get rid of this minus 12. This is minus 12 times x. So in order to get rid of that, I divide by negative 12. And so that gets x all by itself. And then over here, 12 divided by negative 12 is negative 1. Number 6 is very, very, very similar. The first thing we'd like to do before anything else is probably clear the parentheses by distributing the 5. 5 times 8 is 40. 5 times negative 2x is negative 10x. Oh, here we go. So now what do we do next? Are there any like terms that are already on the same side as each other? No. So what we're going to start doing is getting this x all by itself on, I guess, the right side. That's okay. That's a thing. So are we going to get rid of this minus 10 first or the 40 first? It's got to be the 40. So how do I get rid of a separate term of 40? Now, is that a positive 40 or a negative 40? There's a question. Is it a positive 40 or a negative 40? It's a positive 40. This is a positive 40. Gang, this negative applies to the 10x. It's negative 10x. It's a positive 40. So it's a separate term of a positive 40. It's kind of like we're adding 40. But anyway, the bottom line is, how am I going to get rid of this positive 40 term? By subtracting it. And of course, we got to do it to both sides of the equal sign. So that's gone. And what remains on the right side? What's my right side gonna be? Negative 10x. I hope you know. Because this negative, is with it, so it's negative 10x. And then 20 minus 40 is negative 20. And then one more step to get the x by itself. It's negative 10 times x. What's the opposite of multiplying? We divide both sides by negative 10. And that's going to get x by itself, because the negative 10s cancel out. And negative 20 divided by negative 10 is positive 2. And so if you, for some reason, are a little OCD like me, or however you want to describe it, if you're just feeling a little weird about your answer saying 2 equals x instead of x equals 2, you can leave it like this, But, I don't know, maybe we can make it common practice to rewrite our final answer and just say x equals 2. 2 equals x equals 2. Same thing. Maybe a couple more examples, eh? Yep, couple more, just a couple more. And they're similar. There might be a slightly new twist in number 8, kind of. But number 7, the first thing we would do is, that's right, clear the bubble. 7 times x, or 7 times 1x, which is 7x. 7 times negative 2 is minus 14. Bring down the minus 3, bring down the equals 4, and then we check, is there anything I can do on the left side or on the right side before I start moving things from side to side and canceling things? Like, what I'm saying is, are there any like terms that are already on the same side as each other? Turns out yes. Negative 14 minus 3. Those can just combine as is. So negative 14 minus 3 is negative 17. That's all I'm going to do in that step. And now I can just work on getting x all by itself on that left side. So this minus 17 has got to go. So I'm going to add 17 to both sides. 4 plus 17 is 21. And now I would divide by 7 to get that out of there. And so x equals 3. Very good. Number 8, the last example. Oh, what the? How am I going to clear these parentheses? What is being multiplied to the, what is directly outside of this bubble of 3x plus 2? These couple of terms in the parentheses, what's directly in front of the bubble? It's a minus sign, not the 4x. It's a minus sign, which is technically a minus 1. I personally just think of it as being a minus sign, but it's definitely technically a minus 1, okay? Because we're going to distribute the minus sign, or really again, it's like a minus 1. So the 4x comes down, not doing anything with that yet. And then minus 3x, that's going to be a negative 1 times 3x is negative 3x. And then negative with the point, that's going to be minus 2. So this negative makes the 3x negative, and it makes the 2 negative. Just like if we were multiplying by negative 1. Bring down the equal 6. What do we do next? Are there any, because what we would look for next is there any like terms that's already on the same side as each other? Yep. 4x minus 3x, that's just going to be 1x, which, obviously, that's just x. 1x is just x. So I'll write that down in a second. But I got to get it by itself, so all I really have to do is undo this minus 2 term by doing the opposite, adding 2. So 1x is just x. X equals 2 is 8. I mean, I guess theoretically you could have kept this as 1x and then actually went through the motions of dividing both sides by 1. It's a waste of time. So you'd still get 8. So the final answer is x equals 8. And that's section 2.4.